Hello. Today we are going to understand how to convert benzene to aldehydes. And this reaction where we specifically use benzene as a reactant and get a product as a aldehyde, like a benzaldehyde, it's called as a Gatterman-Koch reaction. So let's try to understand how this reaction proceeds. Gatterman-Koch reaction is pretty simple. Actually, it's the simplest in the chapter, in which you have a normal ring structure benzene, and you are going to convert that ring structured benzene to benzaldehyde. Okay, so this over here is the aldehydic group. Okay, either this can be represented as CHO, or in otherwise you can simply represent it as C double bond OH. Both of them mean the same, there's nothing different in it. Let's try to understand under what condition this reaction happens. This reaction requires carbon monoxide and hydrochloric acid in the presence of anhydrous, aluminium chloride, and cuprous chloride. Here, let me tell you one thing. Aluminium chloride as well as cuprous chloride, both of them, either of them can be used, but both of them work as a catalyst. Okay, catalyst is anything that speeds the process of the reaction but does not directly participate in the product formation, right? So this is famously your copper 1, which acts as a catalyst, okay? Even anhydrous aluminium chloride is one of the best catalysts for such reactions of aldehyde. Now, the major question that arises, what happens when we include carbon monoxide in an acidic medium, and how it is directly giving us a benzaldehyde? For which we might have to understand one simple logic, that if this is a benzene ring, we know, right, benzene ring is made up of 6 carbons and 6 hydrogens. We give it as C6H6, right? It's an aromatic ring structure. Now, what is going to happen? As soon as I'm going to add carbon monoxide that we know about, as soon as we are going to add carbon monoxide, where carbon stays in its oxidation state of +2, and HCl, one simple logic that is going to happen, we need to know about this. Hydrogen and chlorine, they separate out as H plus and Cl minus. Okay. And one of the hydrogens of the benzene ring in this acidic medium is going to get eliminated. So this hydrogen which gets eliminated goes to the chlorine, and thereby we get HCl. Okay, so any one of the hydrogen of the benzene ring is going to get eliminated in the acidic medium, and that would be taken by the chlorine or the anion. So we regenerate HCl. Very important reaction where we regenerate a lot of reagents. Okay. Now, our ring has lost one of the hydrogen. Our ring has lost one of the hydrogen. So in place of that, what happens? There would be a carbon attack. Okay, we have lost this hydrogen. So in place of that, there is going to be a carbon attack. In this, the carbon comes and it binds to the available space. Okay, so this binding of carbon to carbon catenation is very preferable, and your carbon will come and join the benzene ring along with the double bonded oxygen. Now, if you look over here properly, okay, what is happening? Carbon has got only 3 bonds in this particular figure, right? Carbon has got only 3 bonds in this particular figure. It requires 4 bonds to be stable, right? 4 bonds of carbon are the stability markers. So what is going to happen? This H plus, which was separated out initially from the hydrochloric acid, it returns over here and it joins this structure. Now carbon has satisfied all the 4 bond parameters for stability, and it has also formed benzaldehyde. So the mechanism is not generally asked in examination, but it is always better to understand how things are proceeding. So benzene rings, one of the hydrogen is eliminated in the acidic medium, and you take it with the anion to form hydrogen chloride. Now the carbon-carbon bond is preferred over here due to the simple notion of catenation. Okay, carbon joins with the other carbon of the benzene ring along with the double bonded oxygen. We know one more thing, that carbon requires four bonds to be stable. So the other bond or the last bond is brought through using this protonate. Okay, so this is how from benzene we can form benzaldehyde using carbon monoxide and HCl. And most of the time in examination, they are going to look for your catalyst as well. So you can't just put the reagents and leave. You need to mention your catalyst. These are the ones that are going to speeden up the breaking and making process. So wherever there is bond breaking, bond making, you need to have some or the other catalyst. I hope you have understood this. And just in case, if you wish to expand your knowledge further, try to find how. See, we know how to go from benzene to benzaldehyde now. If possible, try to find a way to convert benzaldehyde to benzene. Okay, try it up by yourself. How would you convert benzaldehyde to benzene? You can't just reverse the arrowhead and say, voila, it's done. No, it can't be done that way. A hint I can give you that benzaldehyde cannot directly convert to benzene. You need to first convert benzaldehyde to benzoic acid, and then that benzoic acid converts into benzene. So do try to find out how the reverse process happens. I hope you have understood what is Gatterman-Koch reaction. See you in the next video. Signing off. Bye.